In this problem, we've got some interesting maths to do with cancelling out fractions. So let's have a look at what we're given. We're given this strange product of fractions, where we've got 1/2 plus 1 multiplied by 1/3 plus 1 multiplied by 1/4 plus 1, and so on, all the way up to 1 over n plus 1 multiplied by 1 over n plus 1 plus 1. And this gives us 296. We want to find n. Well, this might not be really obvious in where to start out, but let's have a think. If we can stop having these 1/2 plus 1, 1/3 plus 1 involved in each bracket, it might make it a lot easier to look at. So let's try and turn these into improper fractions first. And the way we're going to do that then is if you think 1/2 plus 1, well, the 1 can always be written as the numerator over the denominator with the same denominator as here. So if it's 1/2 plus 1, we're going to get 3 over 2. And for 1/3 plus 1, well, we've got 1/3 plus 3/3. So that's going to give us 4/3. For 1/4 plus 1, well, 1 is 4/4. So we've got 5/4 here. And then we can add in our dot, dot, dot. And we're finishing up with 1 over n plus 1. Well, 1 could be written as n divided by n. So we've then got n plus 1 over n. And lastly, with our 1 over n plus 1, well, 1 could be written as n plus 1 over n plus 1. And then when we add another one on, we end up with n plus 2 over n plus 1. And what we need to remember is we've multiplied all of these together. So we can't forget our times in here. And these multiply to make 296. So that was our step 1, turning them all into improper fractions to make them a bit easier to work with. Well, now if we have a look, we can see something really, really nice about to happen. And it's this. You see a 3 here? Well, there's also a 3 here. Well, that means we can cancel those 3's out. And then we see a 4 in the numerator here and a 4 in the denominator here. Well, we can also cancel out those 4's. And our pattern that we see is because we're adding 1 onto the denominator here each time, these numbers are going to increase by 1 with each step. So the numerator in the first fraction becomes the denominator in the second fraction. And that means this diagonal cancellation is going to continue the whole way along. No matter how long this is, they will keep cancelling out in that manner. So we can trust that the 5 is going to cancel out with whatever comes next. The next fraction would be 6 over 5, and then 7 over 6. This continues all the way till we get here. And we can again have faith that this n is going to be cancelled out by some previous term. The n plus 1 here cancels out with this n plus 1. And actually that means we're left with something much more simple now. The only 2 terms that are left are this n plus 2 on the top, and on the bottom we've got 2. So instead of this really long fraction, we can actually write it as a much simpler fraction, n plus 2 divided by 2. They're the only 2 things that are left. This equals 296. This should be easy for us to solve at this point. We can just multiply the 2 over to get n plus 2 equals 592. times in 296 by 2. And now we can take away the 2 from each side to just get n equals 590.